Hello everyone, these are going to be your notes for Introduction to Probability. So the definition of probability is if the outcomes in a sample space are equally likely to occur, the probability of an event is a numerical value from 0 to 1 that measures the likelihood of the event. So basically what we would have to do is count up the number of the favorable outcome, so whatever we want to happen. And divide that by the total number of outcomes. So in example 1, each letter of the word probability is written on a separate card. The cards are placed face down and mixed up. What is the probability that a randomly selected card has a consonant? So first we have to decide what are the consonants. So in the word probability, we have P, R, B, B, L, T, and yes, Y in this case is a consonant. So counting those up, we have 1, 2, 3, 4, 5, 6, 7 consonants. And then our total number of letters is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. So the probability that we pull a consonant is going to be equal to 7 over 11. Number 2, a spinner is spun and the results are shown in the chart below. Answer the following questions. So this is the spinner right here. Just imagine it spinning around and round and round. Then we record how many times we get the number 1 or the number 5 in the chart. So what is the experimental probability of spinning a 4? When you see the word experimental, that means what from the data did we pull? If I see the word theoretical, that just means what should happen, what we expect to happen. So the experimental probability of spinning a 4, well, first we have to know how many we spun of the 4s versus the total number of spins. So if I go ahead and look at all of the spins, so we spun a 1 8 times, we spun a 2 6 times, a 3 9 times, a 4 11 times, and then we spun a 5 9 times here, and then a 6 7 times. So we need to go ahead and add those up in our calculators. Your total number of spins should have been 50. And the total number of 4s, if you recall, was 11. So the probability of spinning a 4 is 11 over 50. What was the theoretical probability of spinning a 4? Well, in theory, since each of the spaces are equally spaced out on the spinner, there are 6 options. So 1 out of 6. Letter C, what was the experimental probability of spinning an odd number? So the odd numbers would have been 1, 3, and 5. So I need to add those up. So 1 was 8, plus 3, which was 9, plus 9. So go ahead and add those up. You should get 26. So that means the probability of spinning an odd would have been 26 out of 50. But that value can be reduced. It would reduce to 13 over 25. What's the theoretical probability of spinning an odd number? Well, since we have a 1, a 3, and a 5, that's 3 spaces. So 3 out of our 6, which is equal to really 1/2. And again, that's probability of an odd. Letter E, what was the experimental probability of spinning a 3 or a 5? So 3 or 5 was 9 and 9, so that'd be 18. So the probability of 3 or 5 equals 18 over 50. Again, these can be reduced, which would be 9 over 25. The theoretical probability, since I only have in this case 2 spaces on the spinner, so the probability of a 3 or a 5 is going to be equal to 2 over 6, which is equal to 1/3. What was the experimental probability of not spinning a 1? So basically everything except for the 1, which is 6, 9, 11, 9, and 7. So 6 plus 9 plus 11 plus 9 plus 7. That's going to give me 42. So the probability of not a 1 equals 42 out of 50, which again reduce would be 21 out of 25. So the theoretical probability, everything except for the 1. So that'd be 6, 2, 3, 4, and 5. So that'd be 5 spaces. So probability of not a 1 is equal to 5 out of 6. All right, next example. There are 200 marbles in a bag. Each are either red, yellow, green, or blue. The probability of picking a blue marble is 25%. How many blue marbles are in the bag? So since this is a theoretical probability, we can go ahead and easily calculate the number of marbles that are blue by just taking 25% of 200. And that's going to be equal to 50 blue marbles. The next idea we're going to talk about are Venn diagrams. A Venn diagram is a diagram that represents mathematical sets pictorially using circles. In a Venn diagram, all possible results fall inside the rectangle. At a high school, some students play soccer and some do not. Also, some students play basketball and some do not. This scenario can be represented by a Venn diagram as shown below. The circle labeled S represents the students who play soccer, and the circle labeled B represents the students who play basketball. And then the rectangle represents all students at the school. On the Venn diagram, shade the region representing the following instances. So students who play soccer. So all you're going to do is shade in wherever you see an S. So that would be inside here. It's okay that you're also shading in the space that's overlapping with the basketball, because you're just focusing right now on students who play soccer. So students who do not play soccer are going to be anyone outside of that S. You can also go ahead and highlight as well the space around, because there are going to be people who do not play either soccer or basketball, and we will represent those outside of the two circles. So the students who play soccer and basketball is where they overlap, right in here. And then the students who play soccer or basketball is going to be everyone inside the two circles. So this circle and this circle. Letter E says, what would the Venn diagram look like if students were not able to play both soccer and basketball? meaning neither of them. So if you had that Venn diagram, just drawing a quick sketch, that'd be basically everyone on the outside of the Venn diagram. Oops. Good enough, right? When using probability, we sometimes use Venn diagrams and sometimes use things called logic symbols. So the intersection versus a union. When we're talking about an intersection, we're talking about the idea of event A happening and B happening at the same time. The symbols we use are a little caret and B. So the intersection of two circles of the Venn diagram is the region where the two would overlap because both are happening at the same time. A union, however, is just the combined region of both circles. So it's either, for example, from above, either soccer or basketball. So we use an or statement. So A or B. So what that looks like in symbols would be A, upside down, caret, so in this case of V, B. So the sum of all probabilities in this sample space is 1 because that would add up to 100%. The complement of an event E is the set of all outcomes in the sample space that are not E, so everything except for E. So there's a theorem that basically says that the sum of the probability of an event and the probability of its complement is 1. Because if I were to think of, in the previous examples, the probability of spinning not a 1, which was 5 over 6, plus the probability of spinning a 1, which is 1 over 6, well, that just equals 6 over 6, which is equal to 1. Example 4. Fill in the Venn diagram using the following information. There's a total of 200 students in the freshman class. 23 of those students play both soccer and basketball. 130 students play soccer and 85 students play basketball. So in order to do this, we're going to have to piece through the information, and we're going to have to make sure that we're not double counting students. So first of all, we know there's 200 students total, right? 23 of those students both play soccer and basketball. So both is going to be here, 23. 130 students play soccer. Now, that means the entire bubble of soccer is 130 students, but we already know that 23 of those play soccer and basketball. So what we need to do is take 130 minus 23 to get 107. So 107 students play soccer but don't also play basketball. Next, 85 students play basketball. So again, 85 total students play basketball, but some already play soccer as well. So 85 minus 23 is 62. Now to figure out the number of students who play neither sports, you just go ahead and take 200 minus 107 minus 23 minus 62, because that's what we already have. So if you go ahead and put that in your calculator, you would just get 8 students. So let's go ahead and now find the probabilities of all of the different things. So probability that a student plays soccer, that's going to be 130 out of 200, which reduces to 13 out of 20. The probability of students who play basketball would be the 85 students out of 200, which is equal to 17 out of 40. The probability of soccer or basketball is going to be made up of the sum of all of the circles. So 107 plus 23 plus 62 out of 200. So go ahead and calculate that, which is 192 out of 200, which equals 24 out of 25. The probability of soccer and basketball, again, is where they overlap. So 23 out of 200, that one cannot be reduced. Soccer, but not basketball. So that would be anyone who plays soccer, but eliminating the ones who do play basketball. So that'd be 107 out of 200. Also can't be reduced. The probability of neither soccer nor basketball. So that would be 8 out of 200. Which equals 1 out of 25. Example number 5. Of the 195 students in the senior class, 104 study Spanish, 86 study French, and 12 study both Spanish and French. So what we're going to do is fill in the table. First, we should label them as Spanish and French. So Spanish, French. All right, so again, since 12 study both, that'll be 12 here. We know 104 study Spanish, so 104 minus 12 is equal to 92. For French, we had 86, but we need to eliminate the overlap. So 86 minus 12 is 74. And there's 195 students total. So 195 minus 92 minus 12 minus 74 gives us our leftover students of 17 who don't study either language. So let's go ahead and find some probabilities. What's the probability of only French? So that would be 74. Out of 195. Probability of only Spanish would be 92 out of 195. Probability of F intersection S, so French and Spanish. Remember, this just means and. So French and Spanish is 12 out of 195. French or Spanish, so that's going to be everyone in the two circles. So that would be the 92 plus 12 plus 74 out of 195, which is 178 out of 195. Probability of the complement of Spanish, which means everyone except for Spanish. So that'd be 195 minus Spanish is 92 and 12, which we know is 104 from earlier, is 91 out of 195. Complement of French, so everyone who does not speak French. So 195 minus 86 out of 195, 109. And last but not least, probability of those who do not even take a language would be 17 out of 195. All right, let's look at example number 6. There are 3 green marbles, 7 red marbles, and 5 white marbles in a bag. A single marble is drawn from the bag. Find the probability of each event. So probability of not green. So first we should total up the number of marbles. So 3 plus 7 plus 5 equals 15 marbles. So probability of not green would just be 7 plus 5, which is 12, out of 15, which you could reduce to 4/5. Letter B had a little mistake. It says probability of yellow, which we don't have, so it'd be not possible. So let's change that to white. So the probability of white complement, so everything that is not white. So that would be the green and the red marbles, which is 10. So 3 plus 7 is 10 out of 15, which again, you can reduce that to 2/5. And then the probability of not red or white, so we want to eliminate both of those, which really is just back to green. So that would be 3 out of 15, which is equal to 1/5. Example number 7. Taylor has a bag of Starbursts, which are filled with 12 tropical, 10 mango, 13 cherry, and 15 lemon Starbursts. Find the probability of not a tropical Starburst. So first we need to figure out how many Starbursts there are total. So let's go ahead and do that by adding 12 plus 10 plus 13 plus 15. And that would give us 50 Starbursts. So probability of not a tropical Starburst would be everything except for 12. So you can think of that as 50 minus 12 over 50. So 38 over 50. So 38 over 50 reduces to 19 over 25. Letter B says probability of not cherry and not lemon. So we're looking at probability of not cherry with the probability of not lemon. So we're eliminating cherry and lemon. So all that would be left behind is tropical and mango. So that would be 12 and 10 over 50, which is 32 over 50, which does reduce to 16 over 50. All right, last section. A class of 40 students completed a survey on what pets they like. Their choices were cats, dogs, and birds. Everyone liked at least one pet. 10 students liked cats and birds, but not dogs. 6 students liked cats and dogs, but not birds. 2 students liked dogs and birds, but not cats. 2 students liked all 3 pets. A total of 28 students liked cats, 15 students liked birds, and 19 students liked dogs. So we're going to complete the Venn diagram based upon the data. So again, we have 40 students total. And in this case, every student's going to be accounted for. So we don't need to draw a box around the 3 circles because everyone liked at least one of the pets. So 10 students like cats and birds, but not dogs. So we find where cats and birds overlaps, but does not have the circle with the dogs. So we have to look, and what's nice is if you fill this in, kind of like with a highlighter. So cats, birds, and then dogs, like so. That can help maybe visualize more since there's 3 colors and they blend a little differently. So 10 like cats and cats and birds, but not dogs. So cats was pink, birds was yellow, so that should make an orange color, which is right here. 6 students like cats and dogs, but not birds. So cats and dogs, pink and blue, which makes purplish. So that would be right here. 2 students like dogs and birds, but not cats. So dogs and birds, blue and yellow make green. So I'm going to go ahead and put 2 in there. 2 students like all 3 pets, so I can go ahead and put that right there. All right, so now we're going to go ahead and figure out the rest of the pieces, because it does tell us a total of 28 students liked cats overall. Right now, out of that 28, 6, 2, and 10 are overlapping with the other pets. So we're going to take 28 minus 6 minus 2 minus 10 to get 10 remaining kids liking only cats. And then we're going to go ahead and do that for birds and dogs. So birds, there's 15 total students. So 15 minus the overlappings. So 10 minus 2 minus 2, you get 1. And then 19 students like dogs. So 19 minus the overlaps. So 6 minus 2 minus 2, which is 9. Now we can actually go ahead and calculate our probabilities. So the probability of cats and dogs. Remember, this means and. So I find where cats and dogs overlap. Now, be careful on this one. So cats and dogs, it doesn't matter if they like birds or not. So I'm going to focus in on those 2 circles. So right now, that's going to be in here. Okay? So that's where they overlap. So that's 6 and 2, which makes 8 out of 40 students. So 8 out of 40 to 1/5. Probability of cats and birds. So similarly to the other one, I have to look where they overlap, cats and birds. So that would be over here. So cats and birds. I'm looking over the 2 circles overlap, which is going to be 12, because 10 plus 2 is 12. So 12 out of 40, which reduces to 3/10. Probability of dogs or birds. So we're actually going to now be looking at the whole entire circles. So that's going to be the dog circle as well as the bird circle. So every number that's in these 2 circles gets counted, but make sure you only count them once, because if you count them more than once, you'll double count, which we don't want. So let's go ahead and count this. We have 9 plus 6 plus 2 plus 10 plus 2 plus 1. You get 30 out of 40, which is the same as 3/4. Now let's go ahead and do cats or birds. Similarly to the last one, we're going to look at the circles of cats. So cats and birds. So everything that touches those. So basically everything but the 9. So you can also think of it that way. So everything that my pencil captures is going to be included, so that everything on the outside is not included. So you can also think of it as 40 minus 9, which equals 31 out of 40. That might be a faster way of doing it. Probability of birds complement. So we want no birds whatsoever. All right, let's go ahead and do everything that the birds are not touching. So that would be over here. We're going to come around here. Everything, no birds whatsoever. Which is 10 plus 6 plus 9. Which is 25 out of 40, which is 5/8. All right, last one. Probability of cat complement. So everything besides cats. So again, we're going to find everything that the cats don't touch. So that'd be everything out here. Everything here, which is 9 plus 2 plus 1, which equals 12 out of 40, which is 3/10. All right, if you have any questions, let me know.